Okay, I bought this amp off eBay. Paid fairly decent money for it too, because I was curious again, and it was shipped well and no complaints there. Heavy little sucker too, right? Um, but the reason I bought it, it was SBE, the same people that make the SBE radios, but this is a old sweep tube linear amplifier, model SB-1-LA. Not a whole lot out there on this one. There is a update model out there, the SB-2-LA, and from what I can tell, the only thing they really changed is the cosmetics. The basically the same amp electronically, but the SB2 it's got a different look in it, but it's the same amp. So most of the information I got is from the SB2, and after I got it going and played with it and stuff, it took me a minute because it's a little different. I wouldn't say weird, but a little different. And one of the things that I found is, it's got the regular power switch there on and off. Well, actually, filament. The filament is the first one in line on the ACs, and it turns off, all the AC on and off. But when it's on, and this one's off, only the filament's on. This one marked power turns on the high voltage transformer only. But my thing is, it's okay to mark that power. A lot of them, mark it high voltage, but why in the world would you mark it low and high? Why? When all it does is turn the filament power transformer completely off or on, even if the filament is on. So that one, I like the filaments if this one's off, and then when you turn this one on, it turns on the high voltage. It's not a low and a high. And even in the manual, for the SB2, and the SB2 is marked the same way, it tells you that on low, there's no high voltage, and it's not going to key either, because the relay line or the keyer line is in series with that double pole, double throw, it might be a single throw relay. So you can't key it, and you're going to have straight through on low, and they call that straight through, whatever the transceiver, the radio, or the driver, because this amplifier has no driver. So it requires about 60 watts, they say, to get it up to full power. No driver tubes again. So on low, basically what you put into it, you get straight out, through it. It doesn't do anything. So why do they call that low? Even in the book they say that. Then on high is basically putting it in an operation where you turn on the high voltage and you could key it down. So a little weird, a little different. Took me a minute to figure that one out. Then over here you got your tune and operate. Then that is basically your low side, high side, tune cap, ham amplifier with 15 through 80 meters, 15, 20, 40, 80. No 10 meters in this amp. No, mods really. You can always mod it, but it's no easy mods like cut a switch here or remove a screw here to get your 10 meters on this amp. And then there's load. And it's interesting to me, no 10 meters, whereas the SB2, which I did find information on, was made in 1965. So this one had to be made before 65, maybe 63, 64. And the FCC, wasn't banning 10 meters, back then. That didn't come until the late 70s, right? But doing some more research, this amplifier was designed to make with a transceiver the that SBE made at the time, the SBE 33 or 34 transceiver. and the transceivers only had 15 through 80 meters, and since this was made to match it, this also had 15 through 80 meters. A little different. There's some more different stuff about this amp, and one is all 6 sweep tubes, all finals, and I'm like, okay, you don't see that configuration too often. And since I might want to play with some sweep tube amps I got, like a Palomar 300A or Palomar 350Z, and maybe mod 1 or 2 to all 6 finals instead of true drive and 4, is the main reason I bought this. Is I wanted to see what they did, or how did they configure the 6 sweep tubes to be all finals. So if you notice here, and I saw this on one of the ham sites, somebody said, hey, it looks like something's missing, and they would be right, just looking at the tubes and the wires running there. There's no parasitic suppressor at all, at least on the output side or the plate side of these. However, on the ham side, because this amp got really good reviews on the ham side, it's interesting that hams often spew hate on sweep tube amps. However, there are quite a few sweep tube amps that are more or less made for hams, and they all get good ratings. And for me, except for like a key-in circuit and driver, there's basically no difference between a ham sweep tube amp and a CB sweep tube amp. So it's interesting to me, all the hams that hate sweep tube amps, and yet you go to eHam and other places, and it's got like 4 3/4 stars out of 5 on this amp. But anyway, no parasitic suppressors. However, the ham site says, well, yeah, they got away with that because they use a parasitic in the grid, and this is grid driven, so they basically use a parasitic in the drive to keep it from oscillating and feeding back. And I guess it works as if you keep the drive from feeding back, and it's going to stop the output from feeding back too, right? What goes in goes out, or in dirty out dirty, so they clean it up on the input side. Normal stuff, your tune cap, load cap, your band coils, with 15 meters and no provision for 10. What I did is that coil was closer together for 15, and I just spread it out some, so it will tune on 10 now. I kind of tuned it halfway in between 15 meters and 10 meters, so it's basically set up for about 12.5 meters, 12.5 meters, but it will tune on 10 and 15 meters now. Just basic stuff. Switch in some extra caps for the 40 and 80 meter. Switch in some extra cap on the tune side here, and on the load side there. Your band switch under there. Other than playing with the coil a little bit, I did no mods on that. Left it factory. Another thing's a little different on this amp. It uses 2 sets of, even though it's one high voltage transformer, that's the filament low voltage transformer, and that's high voltage only. That high voltage has 2 dual outputs, and they're in series, and it uses 2 voltage doublers in series for the final. And you can see that on the schematic if you could read schematics. Those are highlighted with the yellow right there. You got a bridge here and a bridge there. Well, that's not a bridge, I'm sorry, that is a voltage doubler, and that's the caps to these voltage doubler circuits right there. So it uses 2 of them in series for the high voltage. That there's the bias, because this again is grid driven or turbocharged, and it has voltage off the screen, so it's got to have the bias there. One other thing that's different, and you know, again, I said the reason I bought this to see how they especially did the input of those 6 tubes. Well, most sweep tube amps are grounded grid. Since this one is grid driven, which is high impedance when you drive it on the grid. Grounded grid is usually a low impedance, you know, closer to 50 ohms on a low impedance, but grid driven is high impedance, more like 10,000 ohms, somewhere around there. And radio or driver can't handle, you know, driving something that high. It's got to be low, so to get a good match. So what SBE did here, they put all these resistors here in series parallel to bring that high impedance down. This is your input coming in, you know, your drive coming in, and when you key down, it goes through all those resistors to ground, and then through that cap and into the tubes, into the grid 1 there. That's your drive going in, right? So they did put all these resistors in. Kind of reminds me of a Pride KW1. Pride KW1 was high drive during the FCC crackdown, so it couldn't be they couldn't sell it as a low drive amplifier because of the FCC. So they put all these resistors in the Pride KW1 and made it a high drive, you know, because the resistors were, you know, sucking down all the power coming in. And that's how they were able to sell that or market that and get past FCC. But anyway, this was sooner than 65, so they didn't really need to do that, but they did it again because it's grid driven, and instead of a tuned input to get that input match right, they used all these resistors, which are actually over here on the other side. It's late, my old dog is messing around. I woke him up. But that's all these resistors right here. All of those are that tuned, well, not tuned, but go to the input to get that high impedance on the grid of the input to get it down low. So that's what they use on this amp, and again, that's the schematic on it. This amp is also a little different. It was made to be used or drove or keyed with a SBE, like I say, transceiver of the day, 3334, which was a matching transceiver of it back then. So the transceivers would key the amp, but how the transceivers this was made for did it, they put 10 volts coming from the transceiver into the radio, or into the amplifier to key this amp. Almost every other amplifier, when you key it, you ground the relay. You know, it's got power on one side and you ground the other side. When you hit a foot switch, normally it goes, you know, from the cold side of the relay to ground, and that's why it keys the relay. On this amp, it's backwards because it was designed for 10 volts to come from the transceiver, you know, through the into the amp to key the amp. So hardly anything, you know, has 10 volts in it. So I did a little mod on it. I took the negative 10-15 volts right here. This is the filaments. Then that diode there, you know, gives you some negative low voltage, and there's the cap on it. So that's already there, and it was close to where the relays are. So I just rewired it, so it's got negative voltage going to the relay. These relays don't care, you know, if it's negative volts or positive volts, you know, going to them. They don't care. They just want, you know, the proper voltage. And then you just ground the relay like you normally do, you know, with a foot switch or another, you know, transceiver radio that normally grounds the relay. Another thing was that with the 10 volts, it would activate this relay here, and then this relay here would kick in and it would activate the main relay. It's like a relay controlling a relay. And then this relay would, you know, key down the antenna and you know, the radio coming in and the antenna, the watts going out. And also the center leg would ground the bias. However, the bias has a negative 120 volts or so on it. And the mod you see on the net for this amp for other hams is this here. That's not factory to add that RCA jack and to ground it there using a normal foot switch. That's grounding that 120 line, which would take it down to like 50-60 volts of operating, because the bias, you know, cuts the tubes off so they're not conducting, you know, during standby. And then when you ground that line, it's got the resistor, so you're not grounding it, you know, to 0. It's grounded down to about 60 volts, and that's your, or negative 60 volts, and that's your operating bias. So the ham sites say, you know, hey, add a relay jack here and put your foot switch or your radiator there, and you could ground it. You can ground that 120 coming in there. However, with that setup, you got 120 volts going to your foot switch, or negative 120 going to your foot switch, and or if you're using a radio or transceiver, you know, to key up the amp, you got a negative 120 going into your radio. So that's not the best idea either. They do make isolating, you know, key up things. I think Ameritron makes one that's pretty popular that you can put in between there that would kind of isolate that. But what I did is I kind of rewired these relays. Not only do you ground it, I redid it so this relay doesn't key the other relay. I do them both at the same time with the 10 volts. And then this relay grounds that 110 line, that negative 110 line. So using a foot switch the way I did it, you only got, you know, 10-15 volts to ground like a normal amplifier has, and it doesn't mess with that 120 volts. So I think that's about all the weird stuff. Oh, there's one more that I haven't got to. That there is the center of that other relay, and it's like a slow start or soft start, but it's a configuration I had never seen before. Two things about this: when you're in receive, it's in permanent slow start mode, where that fuse and that resistor are in line, and you know your power's going through here and over here because that's open, you know, in receive. Now when the relay transmits, that leg closes and it bypasses all that. The power goes straight through over here, only in transmit. So when long as it's not transmitting, it's got that fuse and that resistor in line as a slow start, like a permanent slow start or soft start until you key down. Most amplifiers nowadays, they only do that soft start initially when you first power the amplifier up, not, you know, when you key down. So normally they have like a little time delay on that, and when you key down, when you first power the amp up, that slow start resistor kicks in, and then after a few seconds the relay kicks in and bypasses that. However, on this one again, it's in line all the time until you actually transmit, and then that line bypasses it. But one thing I find curious about that is when you're transmitting, you're bypassing that fuse. That fuse is no longer active, you know, when you're transmitting, which is very interesting, because you have a glitch or, you know, a short in the tube or something with the high voltage pop shorts or whatever, that fuse is no longer active, you know, for that in line, as long as you're keyed down. I kind of find that, you know, pretty interesting with this amp. So anyway, I think that's it for my walkthrough with this amp, I'm gonna do one with it powered up, you know, coming soon. But this is the SBE SB-1LA with 6 MH6, 6 LQ6, 6JE6C original finals in it with the black top. Those are probably worth a little bit of money right there. And just a few mods, you know, with the way I did the relays, and the got rid of the positive 120 on the key up. And this is the back of it. They use a 9-pin octal for the power plug. Oh, they use a RCA jack for the drive coming in. That's your power or radio or driver coming in, an RCA jack. I didn't have this little come on camera, where am I? There you are. I didn't have this little adapter here. I just bought that so I could just use the adapter here to go to the regular RG fitting. So I didn't have to, you know, do any mods on that. So pretty clean, you know. It's not mint, but again, this amplifier was probably made in 1964-ish, 63, 64, because his newer brother came out in 65. So SBE SB-1LA 6 MH6, 6 LQ6 sweep tubes with the black top. Those are supposed to be a little bit heavier and more robust than some of the modern tubes. Sweep tube amplifier. Alright, that's it with this walkthrough on this one. Bye.